Hello everyone, welcome back to the channel. Today we are going to clear up one of the most confusing topics in basic chemistry, that is atomic number, atomic mass and atomic weight. So they sound similar but they are not same. By the end of this video you will understand each term clearly with simple examples. So let's get started. So first of all, we understand about atomic number. So atomic number is represented by Z. So what is meant by atomic number? Atomic number means total number of protons in the nucleus of an atom. So atomic number means number of protons in the nucleus of an atom. So atomic number is represented by Z. It determines which element it is. Means it is the identity of a element. Atomic number is a identity of a element. So from atomic number we can determine which element it is. So we take here an example of some atomic numbers. So hydrogen having atomic number 1. So when we see the periodic table, in the periodic table hydrogen having atomic number 1. So means here one proton is present in the hydrogen atom. Carbon having atomic number 6 means total number of 6 protons present in the carbon atom. Oxygen having atomic number 8 means 8 number of protons present in the oxygen. So in this way we can identify atomic number. Now we see here next term, that is atomic mass, or we also call it as a mass number, and this atomic mass or mass number is represented by capital A. So what is meant by atomic mass or mass number? The total number of protons plus neutrons in an atom. So atomic mass or mass number is a total number of protons plus neutrons in an atom. It is represented by capital A. It is represented by capital A. So atomic mass means total number of protons plus neutrons. Now we understand atomic mass with an example of carbons. So carbon having atomic mass 12. So why this 12 mass of carbon? So carbon consists of 6 protons and 6 neutrons. So atomic mass means total number of protons plus total number of neutrons. So this is the atomic mass. So that's why atomic mass of carbon is 12. Now we understand atomic mass of oxygen. Atomic mass of oxygen is 16. Means in oxygen 8 number of protons and 8 number of neutrons is present. So atomic mass is equal to 8 protons plus 8 neutrons. So this is 16. Atomic mass is 16 for oxygen. Atomic mass is always a whole number because it counts particles. Atomic mass is a whole number because it counts particles. Now we understand about atomic weight. Now we understand about the atomic weight. So what is meant by atomic weight? It is a weight average mass of all naturally occurring isotopes of an element. Means it is a weight average mass of all naturally occurring isotopes of an element. Means suppose we consider here carbon. As we know that carbon having different isotopes, carbon 12, carbon 13. So it is a weight average mass of all the isotopes of an element. What is meant by isotopes? As we know that isotopes having same number of protons, different number of neutrons or different mass number. Means isotopes having same number of protons, different number of neutrons or different mass numbers. How we can understand? We taken here an example of carbon. Carbon has isotopes, that is carbon 12, carbon 13. Now we have to calculate here the atomic weight of these isotopes. So how we can calculate the atomic weight? We have formula, that is mass into abundance plus mass into abundance plus dash dash dash. Means this is for first isotope, this is for second isotopes, and this is for if the element having different isotopes, 3 or more isotopes, then we can add in this way. So mass into abundance plus mass into abundance plus mass into abundance in this way. So here we see carbon having two isotopes, that is carbon 12 and carbon 13. Now the abundance of carbon 12 is about 98.9%, but we cannot use this abundance in this formula. We used it is in a fraction form. We used it is in a fraction form. So we first of all understand carbon having two isotopes, suppose carbon 12 and carbon 13. So carbon 12 having abundance 98.9% abundance. This is a percentage abundance of carbon 12. So it is very abundance, means more abundance of carbon 12 is found in nature. So carbon 13 is 1.1% abundance, means it is very small amount. So it is a small amount. Carbon 13 found in nature, that is in a small amount, that is 1.1% abundance. So small amount of abundance of carbon 13. But we cannot use this percentage, we used fraction. So we create a fraction in this formula. Here we used a fraction value of abundance, but this is a percentage value of abundance. So but abundance must be fraction form, not percentage. So how we can convert this percentage into fraction? See that 98.9%, okay, becomes 0.989. So we take this value percentage as a fraction, 0.989. So how we calculate this? See this. This is a percentage form, that is 98.9%. Means this is this means 98.9 out of 100. 98.9 out of 100 means 98.9 percentage means 98.9 divided by 100, that means 0.989. So this fraction value we used here. This fraction value we used here. Now carbon 13 having abundance 1.1%. 1.1%. So this is in a percentage form. We convert this percentage into the fraction. How we can convert this percentage into the fraction? See this. 1.1% becomes fraction in the fraction form, 0.011. So how we convert this percentage into fraction? 1.1% means 1.1 out of 100. Means 1.1 percentage means 1.1 divided by 100. So we get here the fraction value. So this fraction value we used in this formula. And what is the mass? See here, this 12 is mass for first isotope, this 13 is a mass for second isotope. So for first isotope 12 mass and abundance value in a fraction, that is about 0.989. So this is a abundance of this isotope plus mass, that is second isotope. For second isotope mass is 13. What is the abundance? 0.011 is a abundance. Now we are calculate atomic weight for the carbon. Mass into abundance plus mass into abundance. Means mass for first carbon isotope is 12, abundance is 0.989 plus mass for second isotope of carbon is 13 and abundance is 0.011. So 12 into 0.989 becomes 11.868 plus 13 into 0.011 becomes 0.143. So this is about 12.01 AMU. So this is a atomic weight of carbon. Now we take another example to understand atomic weight. We take here example of chlorine. Okay, so chlorine having two types of isotopes, chlorine 35 and chlorine 37. So chlorine 35 have 75% abundance and chlorine 37 having 25% abundance. So we not used here percentage, we used here the fraction. So that means 75% means in the fraction form 0.75 and 25% means in the fraction form 0.25. What is the mass for first isotope? 35. What is the mass for the second isotope? 37. So mass into abundance plus mass into abundance. So this is a atomic weight. So 35 into 0.75 it becomes 26.25 plus 37 into 0.25 it becomes 9.25. So 26.25 plus 9.25 it becomes 35.5 AMU. So this is a atomic weight of chlorine. So when we see the atomic weight for some isotopic form of element appear in a decimal form. So why this decimal? So most atomic weights are in a decimal because elements exist as a mixture of isotopes and each isotopes contributes differently. So we see here elements observed in a different isotopic form and each isotopes contribute differently. Only element with one dominant isotope have nearly whole number. So when this whole number is appear, those elements having one dominant form is appear. So this for this type of element the atomic weight appear in the whole number. So here are the some examples of atomic weight of some common elements. So when we see here there are some common elements used here. Hydrogen, symbol of hydrogen is 1, sorry H. Hydrogen element is hydrogen, symbol is H and atomic weight is 1.008. For helium symbol is He and atomic weight is 4.0026. For lithium symbol is Li, atomic weight is 6.94. For beryllium symbol is Be and atomic weight is 9.012. For boron symbol is B and atomic weight is 10.81. For carbon symbol is C and atomic weight is 12.01. For nitrogen symbol N and atomic weight is 14.01. For oxygen symbol O, atomic weight is 16.00. For fluorine F, atomic weight is 19.00. And for neon symbol Ne and atomic weight is 20.18. So here are these are the some examples. Now what is the conclusion of this all the topic? Atomic number means number of protons. So it is identity of atom. Atomic number means number of protons and it is identity of atom. Atomic mass means total number of protons and neutrons. So this is for specific atom and this is a whole number. Atomic mass means total number of protons plus neutrons and this is for specific atom or appear as a whole number. And what is meant by atomic weight? Atomic weight means average of isotopes. So it is a average of isotopes. So if this video help you to understand chemistry better, don't forget to like, share and subscribe. So thanks for watching. Thank you.